Hello, this is Professor Teixeira, and I'm going to show you how to do a hypothesis test for a population proportion. And I'm going to use this example we had in class, a Pine Creek golf course. And one important piece of information is this: 20% of players at Pine Creek were women. So I'm going to use this piece of information in the null hypothesis and the alternative hypothesis. And the manager wants to determine if the proportion of women has increased for more than 20%. So my null hypothesis in this case is that the proportion of women is smaller or equal to 0.2. And the alternative hypothesis is that the proportion of women now is greater than 0.2. Okay, and to solve this problem, I'm going to use this file in class, mean unknown. I download that from OAKS, and I'm going to use this worksheet proportion. Okay, and here is the sample we have, indicating if the golfer is a woman or a man, and so on. Okay, so let's use this file to solve this problem. The hypothesized population mean in this case is the proportion we have is not a mean, is a proportion we have in the hypothesis. Okay, so the proportion in the hypothesis is 0.2, like I told you. And then I have to count how many female we have in our sample, and how I do that is type equal count if, open parenthesis, and then I have to select a range, which is the entire range of our sample, and then I type comma, and then I have to determine what the criteria I want to count females here. To do that, I open quotation marks and I type female, because this is the word in my sample that I want Excel to count for me. So this is telling Excel that in this entire range, I want Excel to count only what says female, and then close parentheses, and then we have 100. I cannot come with the sample proportion before knowing how much the sample size is, so I'm going ahead and count how many cells we have in our sample. Okay, how much is our sample size? So I'm going to type equal count A. Okay, this is the function count A, because we don't have numbers here, we only have words. So I have to use count A, and then open parentheses, and then select the entire range of cells, and then close parentheses, and then I have 400 my sample size, and 100 females. Now I can come up with the sample proportion. The sample proportion is going to be equal to the amount of women I have. This is the information. This is the sample that I'm interested, the proportion of women. So I have to select the female divided by the sample size. So I want to know the proportion of female in the sample size, and then type enter. It's 0.25. Okay, now I can come up with the standard error of proportion. I'm going to correct that. This is proportion and not mean. I can come up with the standard error of proportion. To do that, I'm going to use these cells next to it to be able to do it. Remember that the formula for standard error of the mean is the square root of the proportion hypothesized multiplied by 1 minus the hypothesized proportion divided by n, and this is what we are going to do here. So I start with the numerator, which is proportion hypothesized, which is equal to 0.2. This is the proportion hypothesized, asterisk, which is multiplied, open parenthesis, 1 minus the proportion again, and then close parenthesis. Then I'm going to divide this resulting number here by the sample size. This is what this is saying, divide by the sample size. So equal this number divided by the sample size, this cell. Okay, hit enter, and then I can take the square root. The square root is going to be equal SQR RT, open parenthesis, and then the number we just found here, close parenthesis, and then we have the standard error of proportion. I like to have everything organized, so you can like put this resulting number here by simply typing it, or you can do equal this number, and then you have 0.02 here. Now I can come up with my test statistic for the difference between the sample proportion and the hypothesized proportion. So I can come up with my z. So my z is going to be equal to standardize. I'm going to use the function standardize. Open parenthesis, I'm going to standardize one number. The number I want to standardize is 0.25. Then type comma. Considering a mean. This mean is the hypothesized proportion. And then type comma. And then you have to come up with the standard deviation, which is the standard error of proportion. You enter these three pieces of information, close parenthesis, type enter, and then you have the test statistics, which is the z is 2.5. Now I have to come up with the confidence level and alpha and everything. So let's go back to the problem to see if the problem says anything about confidence level, and here is the information I was looking for. The level of significance is 0.05. So because it's 0.05, I can move directly to the significance level, the alpha indicated by the problem, 0.05. In this case, I don't need to come up with these two pieces of information because I have this number directly from the problem. The problem is giving me the significance of level, so go ahead and type that. Okay? Then comes one important piece of this exercise. You have to figure out if this is a lower tail test or an upper tail test. You can figure out that by looking at the hypothesis, especially the alternative hypothesis. In this case, the alternative hypothesis is that the proportion is greater than 0.2. How can I know that? It's because the manager wants to determine if the proportion has increased more than 0.2. So because of that, has to be higher, has to be in the upper tail, higher than a given number. So this tells me that is in the upper tail. So if it is in the upper tail, I have to perform this computation here, equal 1 minus the significance level alpha. I do that, and then I have the entire area up to the upper tail, which gives me 0.05 above the upper tail. Okay, so this is the reason I'm doing that, because this is an upper tail test. If it is a lower tail test, you simply use this number. Okay, all right, so I'm doing this because I have to come up with the z critical to test the hypothesis. So this is what I'm going to do next, is come up with the critical z. Okay, this is a one tail test. I can come up with only one z on the upper tail to match this problem. So the z, how to find the z here? Z equal norm.s.inv, open parenthesis, and then choose the probability, which is this probability here, and then close parenthesis. Hit enter, and this is the z in the upper tail. The z in the upper tail in this case is 1.64. Okay, so now I can compare my z I found on my test with the z critical, and the rule is, I'm simply adjusting the format here. So let me compare, and the rejection rule is, if the test statistic I found is higher than my z critical, I reject the null hypothesis. So this is what I'm going to do. 2.5 is higher than 1.64. So I reject the null hypothesis and conclude that the proportion of women is higher than 0.2 or 20%. This is what we have in the alternative hypothesis. So if I reject the null hypothesis, I conclude that the proportion of women is higher than 0.2, which is 20%. You see that is messy. The format here in this cell is messy. So I select these 4 cells, which is painted as blue. And then I come here on alignment and click merge and center. And I go up and click wrap text and becomes beautiful. Okay. So I'm done with the critical value approach. Now I can use the p-value approach to solve the same problem. Now I'm going to test what's the probability that this 2.5 happen in a distribution of z. I'm not going to use the lower tail, I'm going to use the upper tail, right? So in this case, I'm going to do both so you can understand the mechanics always. So the lower tail, the probability of the lower tail is going to be equal to norm S dist open parentheses, and then I select the z I'm looking for, which is this, and then I type comma, and then where it says cumulative I type 1 close parentheses and hit enter. This is the probability on up to this point in the upper tail. Remember, this comes from the left of the distribution from like minus something up to 2.5. So this is the reason it's too big, this probability. The area is too big. So what I'm looking is what is after that. What's the probability after this number in the distribution? So this is what I have to do next, is equal 1 minus this probability. So because this is an upper tail test, this is the probability that matters. This is the probability that counts. This is what you have to use because it's an upper tail test. And I simply use this to come up with this number here, okay? Now that I know the probability in the upper tail, I can compare this probability with the significance level. And I know that this can be confusing because different amount of decimal places. So I go ahead and reduce the decimal places of this number. I'm gonna do that here. So I reduce the number of decimal places. I go here to centralize to be beautiful. And now I can compare. Compare this p-value with the significance level. The rejection rule says that if this number is smaller than this number, you reject the null. 0.01 is smaller than 0.05, so I go ahead and reject the null and conclude that the proportion of women is higher than 0.2 or 20%. Okay, and then you like go here, wrap text, and becomes beautiful this format. And if you go back to the problem says that there was an effort to increase the proportion of women. They implemented a special promotion. Okay, so if you are the manager, if you made this effort, if you made this campaign, this promotion, you should be happy because it worked. This is what you have to tell in your meeting with the director. This is what you have to do in your meeting with the CEO of the company. Listen, we did a marketing promotion and I can prove to you that we have increased the proportion of women in our golf course. Okay, so the market campaign worked. Here is the proof, here is the evidence. This is how you use statistics. This is the purpose of using statistics and learning statistics. Okay? All right, thank you. Bye.